So we need to know about solar geometry. We need to know what is latitude of location, declination, that is delta, W is hour angle, solar azimuth angle, slope S, and alpha altitude angle, zenith angle, etc., etc. So let us consider this diagram. So by using this, let us know about the solar geometry. That is nothing but the solar radiation geometry is for the analysis of solar radiation, and it is essential to understand the radiation geometry and the related solar angles. So here in this diagram, various solar angles are illustrated. So consider this horizontal plane on the Earth's surface. Let the sunrays pass through this plane. That is, this is the sunrays passing through this plane. This is the tilted plane actually. This is the sunrise and this is the zenith. That is nothing but what do you call it is atmosphere. ಖಗೋಳ ಅಂತ ಹೇಳ್ತಾರಲ್ಲ ಅದನ್ನ ಜನಿತ್ ಅಂತ ಹೇಳ್ತೀವಿ. So this is sun. This is made. The sun rays are made to fall on the tilted surface of this plate. So this is the west, east-west direction. This is north-south direction. Here it is mentioned this north to south and east to west. As we know, while considering the orbit, it is in the Earth surface will be in the elliptical shape. So let us know about this. That is incident angle. That is nothing but theta. So here one normal line is there. Here this is normal to the tilted surface. This is the tilted surface and it is normal to this. So here in this case, the angle between this sun rays, beam of rays falling on the surface and to the normal is nothing but incident angle. That is nothing but theta. So it is the angle made between the incident beam. This is incident beam and the normal to the tilted plane. This is one more line is there. This is here you will find this almost normal to this. That is the angle between this line and this line is nothing but theta. So if one is the intensity of the solar radiation with the incident angle theta, then the flux or radiation intensity falling normal to the surface is given by 1 cos theta. So here next you consider altitude angle or solar altitude angle, and that is alpha. This is nothing but this is nothing but alpha. So that is altitude angle or solar altitude angle we call. It is the vertical angle made between the projection of sun rays and the horizontal plane direction of the. This is the horizontal plane direction of the sun rays, and this is the beam of radiation. So this is nothing but alpha. That is altitude angle or solar altitude angle. What we calling it as alpha. So next is we need to know about zenith angle. That is theta z. This is the theta z. We know this is zenith. This portion is zenith. Okay, it is the angle between the sun rays and the zenith vertical line extended to the horizontal surface. This is the horizontal surface extended this line. So the beam of rays will be falling here, and that is perpendicular to the tilted plate. So the angle between this beam and the tilted place is nothing but zenith angle we are calling. So the zenith angle is between the sun rays and the vertical rays which is extended from the horizontal surface, and the point where the east and west north and south axis intersects. That is east and west, north and point intersects. This is the extended line of the from the zenith. So the complement of the zenith angle is the solar altitude angle alpha. Hence, theta z can also be equal to pi divided by 2 minus alpha. That is pi divided by 2 minus alpha. So this pi divided by 2 minus alpha is nothing but zenith angle. Next is solar azimuth angle. Here it is the angle between the horizontal projection of the sunrise and due to the south line going to the clockwise direction. This one is called as gamma S. This is nothing but solar azimuth angle. These are the horizontal lines which are going here, solar horizontal lines, and from here to here, this plane is nothing but solar azimuth angle. It is the angle between the horizontal projection of the sun rays and the due south line going clockwise direction is nothing but solar azimuth angle. Next one is what do you call surface azimuth angle. That is plane gamma. This is here in this case. This is surface azimuth angle. This one you can see here. It is the angle made between the horizontal projection of the normal to the tilted surface and the due south line measured in the clockwise direction. By convection, the azimuth angles are taken to be positive when measured south to east and negative when measured from south to west. Okay, and also one more is what do you call this one? The slope. It is nothing but beta. This one is beta slope. It is the angle made by the plane surface receiving the solar radiation when the horizontal. It is taken as a positive for a surface sloping towards the south and a negative of surface for a surface sloping towards the north. And another one is this one. That is hour angle. That is W. It is the measure of time, and it is equal to 15 degree per hour. It is measured from noon based on the local solar time or local apparent time. What we are calling it as LAT, local apparent time. So being positive in the morning and negative in the afternoon. So there are a lot of equations for this in order to come across. So we are not interested in calculation of this thing by using formulas, but we need to know local apparent time. The local apparent time is nothing but the time required to be used for calculating the hour angle in the above equation by using different equations regarding this hour angle, latitude angle, and other things. So by using, we are going to calculate a local apparent time, that is LAT, right? So once again, let us go to this. The zenith angle is it is a complementary angle of sun's altitude angle. It is a vertical angle between the sun's rays and line perpendicular to the horizontal plane through the point, that is the angle between the beam and from the sun and the vertical. Next is solar azimuth angle. It is the solar angle in degrees along the horizontal east or west of the north or south. It is a horizontal angle measured from north to horizontal projection of the sun's rays. This angle is positive when measured west measured clockwise. Next, the slope is it is the while coming to the slope, it is the angle made by the plane surface with the horizontal. It is taken to be positive for the surface, slapping towards the south, and a negative for the surface sloping towards the north. Now, once again, let us explain this surface azimuth angle. It is the angle of deviation of the normal to the surface from the local meridian, the zero point being south, east positive and west negative. And while coming to incident angle, it is the angle being measured between the beam of rays and normal to the plane. Next is local time. What I told earlier is local apparent time LAT. We are calling it as LAT. The time used for calculating the hour angle in all the equation, but those equations are not mentioned here because we are not going to calculate or we are not going in depth for calculation and of all these things. So, by as the purpose of explanation, we are saying by using the equations uh, is a local solar time or a local apparent time. It does not coincide with the local clock time. The solar time can be obtained from the standard time observed on the clock by applying two corrections. The first correction arises because of the difference in latitude between the local and the meridian on which the standard time is based. The correction has a magnitude of 4 minutes of every degree difference in longitude. The second correction, time correction, is due to the fact that Earth orbit and rate of rotation are subject to small uh, perturbation. So this is about solar geometry. So we'll move further afterwards. Okay. Thank you.